Hello Vikings, this is Miss Hames. This is Just the Facts 6.6, Graphing Motion. You should have already watched the FC Speed video and read through the PowerPoint and taken some notes and taken a quiz. And now I'm just going to make sure to go over the basics of graphing motion. Here's the overall Just the Facts if you want to refer back to it. It's on graphing motion or graphing speed. We're going to talk about constant motion, change in direction. Alright, the first one is constant motion. Constant motion on a graph is going to be represented by a straight line. As long as it's straight, not curved. Now this is straight, one's going up, one's going down, but it's still straight. And if you notice, the horizontal line means there is no motion. And we'll talk a little bit more about that later. So let's take a look at this graph. First I want to make sure that you understand what a motion graph is. On the x-axis, down here, we have the time. It might be in minutes, like this one is. It might be in hours. It might be in seconds. But it's going to be the time that has elapsed. And then on the y-axis over here, we're going to have the distance. It might be in inches. It might be in millimeters or centimeters. Or it might be in meters, as this one is here. And if you look at right here, this is like the starting point. This is at the beginning of a race. This is where they started, and then time starts at 0 on this one. Whoops. So this is distance over here, and this is time over here. So let's take a look. At 0 seconds, this person was at 0 meters. 1 second later, they were at about, I don't know, what is that? 2, about 2. And then at 2 seconds, they were at about 4. At 3 seconds, they were at 6. Oh, I see a pattern here. So, let's see. 1 meter, they were at 2, then 4, then 6, then 8, then 10. And if you calculated their speed, which is, speed is distance over time, right? Then you're going to get, let's see, 2 over 1, that would be 2 for this one right here, is 2 over 1, and that's 2 miles per hour. For this one right here, you'd have, 4 over 2, which is also 2 miles per hour. For this one, you'd have 6 over 3, which is, guess what, 2 miles per hour. So when there's a constant motion, it's going to be represented by a straight line. Alright, let's take a look at the next one. Alright, this is a straight line. Oops, my line's not very straight, but the graph line is a straight line. It is also constant motion, but let's take a look. At 0 seconds, this person or this object was at 6 meters. Well, at 1 second, they were still at 6 meters. At 2 seconds, they were still at 6 meters. So my question is, did they move? Nope, they just stayed right at 6 meters away. Here's the starting point, and they just stayed right at 6 meters away from wherever this starting point is. So this is also constant motion, but that constant motion is zero motion. Alright? So a horizontal line is no motion. Alright, so if a constant motion is a straight line, then any change in motion is going to be not a straight line. Alright? It can be like this, where it goes up and down and up. It can be curved. It can curve this way. It can go all sorts of different things. Basically, if it is not a straight line, there has been some kind of change in the motion. They have changed directions, they have changed their speed, whether they've sped up or slowed down, but there has been a change in motion of some sort, if it is not a straight line. Let's take a look at this one. All right. This person went, let's see, these are in increments of 10 meters. So they went, about 3 meters in 1 second, and then up to 9 in 2 seconds. And then you can see they didn't continue. It's not a straight line. It's a curved line. And we're going to talk about what that meant to their speed in just a minute. But it's a change in motion because it is not a straight line. All right. If you're ever not sure, just get a piece of paper and hold it next to the dots and see if it is indeed a straight line or not. This one is not. All right. This one is also not a straight line. There's been a change in motion, right? They went up. Now look, that's straight, but it didn't keep going, did it? It went across. That's straight, but the whole thing needs to be one straight line, and this is not. Each section by itself is, but overall it is not a straight line, so there is a change in motion. It is not constant. All right, so let me also let you know that if there's been a change in direction, then it will go up and then go down. And let me show you what that looks like. Okay, so down here is 0. That's the 0, the starting point, right? So let's say they start here, and in 1 second they've walked 1 meter. So 1 second's here, 1 meter's over here. And then they keep going 1 meter per second, 1 meter per second. Well, now in 3 seconds, they're 3 meters away, right? It's been 3 seconds. You can look down here. And they've gone 3 meters. And then let's say, wait a minute, I forgot something. So I need to run back to the starting line for some reason. So they're going to run back. And they're probably maybe running in the same speed. So they came back. So if there's a change in direction, that means they were walking away, 3 meters away, and then they came back. Oops, sorry, my line's not very good. So even though it's been 6 seconds, they're still back at 0. They're still back at the 0, at the starting point, even though 6 seconds has gone by. Okay, so if you see the line go up and then go down, it means there's been a change in direction. They were going this way, then they came back this way. They might start going back that way again, and they might be going slower or faster. We'll talk about that in a minute too. All right, so here's another example for change in direction. Here at 1 second they were at the 0 point, and then 5 seconds later they were up here at about 16 meters away, and then they started coming back. So 6 seconds later, well, they were back at 15. So they had already moved 1 meter closer back to the starting line. Okay? And then closer, closer, and closer. This is minutes, and this is meters. This is time, and this is distance when you're measuring or graphing motion or speed. All right, and then just a little hint. The steeper the slope, the greater the speed. The steeper the slope, the greater the speed. So, if it's not very steep, just like that, it's slower. Remember, if it's a horizontal line, there's no motion. If it's horizontal line, there's no motion. And then the steeper, the faster. Because it means they're going further away in a shorter amount of time. And this means that time is going more than the distance. Okay? I think I have another one to show you. Yeah, let's take a look at this one. So here you can see they're at 0. Oops, I'm trying to use. Here they're at 0. Oops, sorry about that. 1 second, they go 1 meter. 2 seconds, they've gone 2 meters. 3 seconds, they've gone 3 meters. 4 seconds, they've gone 4 meters. Now, if you'll notice, this is a straight line. up to 4. And if you calculate the speed, remember speed is distance divided by time. So let's say this is 4 and it's at 4 meters. So 4 divided by 4 is 1. So they're going 1 meter per, it says minute. 1 meter per minute. Maybe these are turtles. I don't know, it's kind of slow. 1 meter per minute. And then look here. Whoever this is, whatever this is, turtles, snails, whatever, well, they stay right at 4 meters away for 2 more seconds. So they're not moving at all. They're not moving at all. So they're going 0 meters per minute. Remember, a horizontal line is no motion. And then look here. They go from 6 to 10. They go from 6 to 10 in, let's see, that's the time. So we want to get the speed. Let's see, what's the distance? They go from 4 meters to 20. So that's 16 meters, right? They go from 4, looking over here, to 20, where this is 20. They go 16 meters in how many seconds? Not seconds, minutes, 4. So here they went 4 meters per minute. So this line doesn't have a very steep slope, so it's slower, 1 meter per minute. This one's horizontal, so we know there's no motion, 0. Then this one is a little steeper, so it is faster. And you can calculate it, but it's just a shortcut to know that the steeper the slope, the greater the speed. Okay? You can just kind of look at it and know. If you want to calculate it out, you can, but you can see here that the steeper the slope. All right. All right, I think that's it. Now you should be ready to go, and there's 2 or 3, it looks like there's 3 different sets of graphs that you have to read, and if you get confused, just come back and watch this.